Hey guys, this is all about finding the minimum and maximum of a quadratic function, and it applies to a lot of things in real life as far as projectile motion or cost analysis for businesses. So, by the end of this class or this lesson, you're going to know how to find the axis of symmetry, the vertex in the domain and range of a quadratic function, and also how to maximize or minimize a quadratic function. So the first thing we have to figure out is, does a quadratic function open up or does it open down? If it opens up like this, we have a minimum value. If it opens down like this, we have a maximum value. So it's all determined by the a coefficient, that coefficient in front of the x squared term. So the first thing you'll notice in this one, we don't have a y equals. It always has to be a y equals or 0 equals. So what I'm going to do is I'm going to add y to both sides, and I'm also at the same time going to subtract 10. That way the 10 moves over, the y moves over. So I got negative 5 x squared plus 3x minus 10 equals y. So that means that the a value is negative 5. That makes it open down. Whenever the a is negative, it's going to open down. Just like here, I'm going to add x, okay, y equals 4x squared plus x minus 8. Because that 4 is positive, it is going to open up. As we can see in here, this is the opening up, and so therefore the a is going to be positive. But it's asking me to identify the vertex. So that's part A. The vertex is at that point right in the middle where it starts changing. Okay, so that point is going to be negative 3, negative 5. Okay, because it's opening up, we have a minimum value. Okay, and that value is the y coordinate of the vertex, so that minimum is negative 5. And the domain and range. The domain is the set of x values. The range is the set of y values. So you have to imagine squishing this quadratic function, this parabola, along the x-axis. What's going to happen? It's going to flatten out. And all of these x values are all going to be used. It doesn't matter what x value I plug in, I'm still going to get a y value back. So actually the domain is all real numbers, because there's nothing that's going to make it come out as an error in my calculator. The range, though, that's the one you really have to pay attention to. The range is all the y values. So do you see that all these y values up here, there's a point on the parabola that has a y value in here. Where it stops is right here at that negative 5. There's no part of the graph that's below that negative 5. So the range is said to be any value of y that is greater than or equal to negative 5. Because the parabola is all above that. Here, this one, the vertex is at 1, 5. Because it's opening down, it has a maximum value. And the maximum value is at 5. Okay, the domain, again, is going to be all real numbers. The range, if we look at it, there's nothing on that graph that's above 5. So y has to be less than or equal to 5, because everything's below that. So The reason we talk about that minimum and maximum values is when we get to the graphing and finding the vertex. So there's a 4-step process in finding the graph and the minimum and maximum. Okay, first step is always the axis of symmetry, which is x equals the opposite b over 2a, which we covered in the previous lesson. So in this case, it's negative 4 over 2 times 2, which is negative 4 over 4. So the equation for the axis of symmetry is x equals negative 1. That means that there's a vertical line over here. Okay, the equation of that is x equals negative 1. Coordinates of the vertex. I take this negative 1 and I plug it in. 2 times negative 1 squared plus 4 times negative 1 plus 1. So 2 minus 4 plus 1. All right, that is going to be negative 1. Okay, so my vertex, that point, is going to be negative 1, negative 1. Okay? And so then that's here. Okay? Now, identify the vertex as a maximum or minimum. Again, my A is a 2, so it's positive, so it's going to be a minimum value at negative 1. Okay? And then here comes the trick with the graphing the function. I only currently have 1 point. But if you remember, I can find the y-intercept very quickly. My y-intercept is that c value. Okay? Because it's always on the y-axis. So x equals 0. So if I plug in 0 for x, I get my y int is equal to 1. Because both of these drop out, and that's my c value. So if I plot that on my y-axis, this axis of symmetry cuts it right in half. Guess what? I can reflect that point right over that axis. Oh, I got 3 points, and I can kind of sketch it out in my U. In my next example, I do it again, only now my A value is negative. So it's going to be a maximum value. So again, first step, x equals the opposite of 1 over 2 times negative 1. That's going to come out to be 1/2. Okay, that's my axis of symmetry. Okay, then I take that and I plug it in. Negative 1/2 squared plus 1/2 plus 2. Negative 1/2 squared is going to be negative 1/4 plus, and I do 5.5 because that's easier to work with fractions there. I then put them in common denominators. So then I get 9/4 or 2 1/4. Okay, so my vertex is 1/2, 2 1/4. All right, and this 2 1/4 is going to be a max value. All right, so I'm just going to go 2 and up a little bit. All right, there we go. That's right on that line. Okay, then I got to find my y-int. My y-intercept of this equation is going to be 2 because that's my c value. I plot that. I then reflect it over my my axis of symmetry. They're kind of close together, but I can kind of figure it out and notice that it is opening down. So it's all about figuring out, okay, where's my vertex, my y-intercept reflecting it, okay? In this case, my domain is always going to be all real numbers, okay? My range, because my max value is at 2 1/4, it's going to be all y values less than or equal to that. And then we go on to the business side of things, where you're always trying to maximize profit. here in this case, we got an auditorium. It's going to seat 1,200 people, and they charge $5. But we want to make sure that we're maximizing it. So for every 50 cents increase in price, they're going to get 100 fewer people. So right now, it's $5, and they seat 1,200 people. Well, if they increase it 50 cents, then they would only get 1,100 people. If they increase it another 50 cents, that's $6, and that's 1,000. Okay? So instead of making a table, sometimes we use quadratic functions to do this. So the price is going to be $5 plus 50 cents times x. X being the amount of times that I move the price up. So if I move it once, the price is $5.50. If I move it twice, it's going to be $6. If I move it 3 times, it's going to be $6.50. The people is going to start at 1,200, but I'm losing 100 for every increase. So it's minus 100x. Okay? If I multiply the price times the people, I get how much money I'm going to make, right? That's going to be money I'm going to make. So what I'm going to do is I'm going to FOIL these two expressions out. So I get 6,000 minus 500x plus 600x minus 50x squared. And that's going to equal my money. Okay, that's what I'm going to maximize. So if I rewrite this in combined like terms into a quadratic function, it's going to be negative 50x squared plus 100x plus 6,000 equals my profit. That's the equation that I want to maximize. So I follow the same steps. Okay, I do the x equals the opposite of 100 over 2 times negative 50. Okay, that is going to equal 1. Okay, so that is how many increases I need by 50 cents. So what's going to be my maximum profit? Well, I plug it in. Negative 50 times 1 squared plus 100 times 1 plus 6,000 equals my money. Okay, so negative 50 plus 100 plus 6,000. That's going to be $6,000. $6,050. That's going to be my max profit. Okay? And what happens is, I could also do it with the table, but sometimes it doesn't come out as well. So if you look, 5 times 1,200, that's 6,000. That's my starting price. That's how much money I'm making right now. 550 times 1,100, that's going to be 6,050. Okay, then 6 times 1,000, that's 6,000. Do you notice that these goes up, then comes down? So that must be my maximum price if I'm increasing it by 50 cents each time. I can also look at the graph of this, and this 6,000, that's going to be my y-intercept. Okay? And that's where I'm starting. That's where I'm beginning. $6,000 is what I'm making right now, but I want to maximize that. And in this case, I found my axis of symmetry is 1. My vertex is at 6,050. I reflect this over, and I can graph it so that I can see that I shouldn't go past this point if I want to maximize my profits. And that's how you maximize profits. That's how you graph those things. So work on the notes and then take the pre-assessment.